Hi, hello guys, welcome back to Code with Nani channel. Today we came across a very interesting problem, extra characters in a string. So this was asked in yesterday's problem of the day for that lead code. So from now on the morning, I will upload a problem of the day, as well as on the evening, I'll upload the basic beginners C++ DSA course and everything related to DSA tutorials, as well as basic problems related to DSA. So do check it out my channel. So you'll have two playlists. One playlist is regarding lead course problem of the day, and another playlist for uh, DSSA concepts and problems. So let's get into this video. So what is this problem is all about? Extra characters in a string. So basically they'll be given an input string as, see, suppose they'll be given as leads code. So what we're gonna do is, and we have a given a dictionary d equal to lead code, and another thing is late code. So we want to break. So what we want to do is we want to break this lead string into such a part that it should have a very minimum of number of characters that is outside of this dictionary. Suppose what we can do is we can break this statement as L and lead code. So we'll check in the dictionary. L is present now. This length is 1, comma, and its code is it present in the dictionary? No. What is the string? 1, 2, 3, 4, 5, 6, 7, 8, 8. So so 8. It is not so number of characters that is not present in the particular dictionary is 8. So in another way we can break the statement at here. Okay, we can able to break there itself. So what is the maximum number of characters that is not being present in the array? 1, 2, 3, 4, 5, 6, 7. 3, 2, 7. So this is 7. Another way is we can break the statement in lead as code. So we can break it here. So that will be like lead code. So what is the minimum number of characters that is not being present in the array? That is 1. So that's how. So out of this, which is the minimum? Minimum value is 1. So we had to return the particular value. So how do we approach? So if you think in terms of the solution, how do we approach? So we can use recursion. So why we are recursion? Because we keep on recalling this particular break in specific index from. We can break at L, we can break at E or somewhere else. So it is recalling the particular string. So we can think of it in a recursive solution. So how do we approach this recursive solution? So what is happening? So just observe it. So what is happening? So what is happening is, let's say leads code. Just erase this. Leads code. So what can I do is I can break out at every index. So I can break L and as its code. I can break it LE, its code, and so on. I can break it leads code. I can break it here, and so on. So how does this break statement works? I can break it. Break it. Leads code. So I can break it here, right? So how does this recursion works? Recursion calls means it keep on recursively, it does the same thing. So as L here works, so in this particular substring, it can break E and its code. Right. In this particular string, it can still break E, its code. So until it goes on, until the substring goes until we reach the end of the statement. So if we reach the end of the statement, it means we cannot go further. So we can just return end. Suppose if we go so here, and if the break is here, so we cannot go on further. So it just returns 0. So we can go until 0. So what does each recursion, what does each recursion does? It should return the minimum value, because they are asking what is the minimum uh, what is the minimum substring that cannot be included in the dictionary. So in this particular statement, what is the break where we can divide this into two substring and only the missing character length is s, only the s. If see in this example, say hello. Hello, all are still is in the dictionary. Only the particular string is that is not being present in the dictionary is say, which is the length 3. So just return the 3. So in that way, the recursion goes, and we'll just return the minimum. So for each substring, it should return the minimum value, right? Should return the minimum value. So for each particular string, you should return a minimum value. So in this particular case, so as lead is present in the particular dictionary, so what is the extra things that is needed, because it is 0, because lead is present, so it doesn't add anything related to it because it already been present. So in this code, how does recursion call? S, we just break at S, and you have a code, or else SC, and we have break it, and or ODE, and this this and we have SCOD, and we break it E. Another case SCOD. So it'll just check for this present in the dictionary. What is dictionary? Leet, comma code, comma leet code, right? So we'll just check for whether S is present in this. No. So length is 1. And we'll check for other case. C slash. Oh, it can be ODE. CO slash. It can be DE. CO D, or we can end it there, or else the partial break will be at the end of the string. So what does this? C is not present in the string, so I just return C is not present and 3 is not present, so I just return 3. Both are not present, so we just return 2. 3 is not present, we just return the CODE. So D is present, so we just return 0, because uh, all the characters in the particular string is being present in the memory. So just return COD. So what is returning every substring? We are returning just the minimum value. So just return the 0. So out of this, one character is not present in this one character, and here 3 characters. Yeah, 3 characters. Here 4 characters. So what is the minimum? So the minimum is 1. So 1 is being returned. So it will return 3, it will return 3, it will return 4, and so on. So out of this, which is minimum? 1 is minimum. So for this lead score, 1 is the minimum value. So that's how recursion call works, and that's how it is backtracking works. So just code it, guys. You'll get to know how our algorithm will be implemented. Just going into this problem. So I'll just link the problem statement in the description, so you can just directly go into a link code. So let's just write the recursive algorithm. So guys, so in order to check, so what we are doing, we are checking this particular substring is present in this dictionary or not. So how do we check? We create a map, we create a hash map. Why? Because in order to search in a vector, it takes O of n time, because it will be a linear search, because we doesn't know whether the dictionary consists of a sorted array or not. So if we use a hash map, so we can search the element. We can search the element in O of one time. So which will optimize our solution. That's why we use hash map for that particular dictionary, and we'll iterate to that particular sum. So let's get into this. So let's just create a sum. Let's just create a hash map, an order map. So it is basically of type string comma int, right? Just make it as map for auto and map. So just iterating through the dictionary empty of 5, just increment the string, right? So we are calling the helper function. Just return the helper function. Sorry, guys. There might be my video will hide my recording screen. Just so I'll explain it again. So what we're doing, we're just creating another map and just iterating through the dictionary, and we are creating finding out the frequency of the particular dictionary. Because if we know that if the frequency is more than one, then only the particular value will be included in the dictionary. So that if we search for that particular element, if it is present, we'll just return the value. Otherwise, it will give the end value, right? So we are just calling this helper function. So what does the helper function does? It just take the input string as well as the map and just index for now. We'll just take the index. We'll start from the zero, right? So how does the recursion function works? Let's take helper function. What does this things that it does take string s be the reference and order the map as well as it will take the map as well. What is this? Another thing is int index. Why? Because we will check for the particular index itself. Because if we check the recursion tree, how does it goes? It goes for each index. We goes from the particular index to the other elements. Because see, the first recursion call works on L. The next recursion break will works on LE. Next equation call on LEE. Next equation on LET. So it will look from I equal to 0 to less than string. And for each string we are iterating from. This is E. We are iterating from the particular index plus 1 to another thing. Right? Suppose if we break at L. Suppose if, uh, let's go it again. Zoom in. Suppose we break it, let's code right. Suppose we break it L and there may be each code. So from where we begin? We're beginning from L, it is index right now. We are beginning from index plus 1 to next one, right? Because we're breaking it A from ETS code. So are just incrementing the index in the next recursion call. For that tracking, we're just taking this value as index, right? Just for the index. Suppose if we reach the end of the if index is greater than or end of the string, so what we need to return? We just return 0 because there is no other move. Or else what we do? Or else we'll just loop from particular index to I less than h dot length. So for that, but every index, so we'll just maintain the minimum. Minouts is equal to should be the max value and also a temporary string, because to store at a particular level, like if you are breaking the strings into two, the first half should be maintained in a separate string variable, right? What we're doing is just append each and every value to this particular string as it goes. So fine. See, so if you check out our recursion tree, first we are breaking at L, right? Now the next thing we are breaking at LE. So we're just appending each and every character to this. So that's what is how our code goes, right? And let's check for extra. Let's give this extra. What is this extra? So if we'll check for this particular string is present in the map or not, in the dictionary or not. If it is not present in the dictionary, whatever the length of the string will be stored in the extra, right? If mp dot find of temp is equal to mp dot m, which means this extra is equal to whatever the value of the temp dot length, right? Or else, if it is not, if the length, if it is present in the array, which means we'll take current extra equal to, we'll just recursively call the function again, because because as L doesn't if L doesn't present in the array, and we'll check for the remaining substring whether it is present in the array or not, and we'll check and will that helpful function return the minimum number of characters that are not being present in the dictionary, right? You have to check for other things too, right? So write again for function, let's input the string and pay and the index. So what is the min answer does it? What mean it shows the minimum answer. Minimum of min answer, comma. So what is this extra left part plus what is the current extra? Why we are doing this stuff? Because if you see this, if we break it leads code, if we break it here, what is the part of this? 0 plus. It will check for this S code, right? S slash code. So what is this part? This part is 0 and this part is 1. So I'll just add this. To add this, where this is extra and this is current extra. So we'll just add 1 plus 0 and we'll return here 0 plus 1. Total is the total. Total is 1. So that is the thing where we got this answer. In the final case, we just return min answer. Okay. Alright. This is okay, and for this current extra, we had to increment the plus 1, because in the from the next index we are just checking for the recursive call. So that's the mistake I done. So that leads to overload of the memory. That is why it doesn't run for this input. So why it is giving timely text? Oh yeah, because suppose in a particular index, we'll recall the function from that particular index to the next element, right? So suppose we are calling from this particular index to the next index. Suppose we are breaking it S, so we'll call from code, right? Like suppose we are breaking here from, we are calling from S to COD in the next recursion call. So that's what I mistake, small mistake. Just add I here, particular I plus 1. I'll check for this. Yeah, it run. But even submit, it doesn't submit, because there was too many recursion calls, so that takes too much time to load up, because this particular solution is 2 power n. If you take 2 power 50, it is because it will become more high time complexity. That's why time limit exceeded. So what we had to do is we'll just use a TP to solve the so to solve the to solve the same recursion calls, like to store this as DP values in the particular array. So if If the same if the same recursion call occurs, it will retrieve the data from the DP array. So yeah, I think you all are aware of how DP works. DP works. It will store the particular index, particular data in a DP array. So whenever the same recursion call occurs, suppose same over function call occurs, so you just retrieve the data from the DP array. So let's do it. Let's do it. So what I do is vector int DP n is equal to of s comma minus one, right? Just let's pass the DP array. Just check out on the same thing. Just pass it by the parameter. Suppose we had to write the condition over here. So whatever the recursion call will be the same. If dp of a particular index is not equal to -1, we'll just return the same value that is being stored in the dp array, right? Dp of index, right? And in the end, I'll just write dp of index is like we'll store that particular at the particular level minimum value in the dp of that particular index. That's it. In the final end, we'll get retrieve the result. So that's what is the code it is. So we'll just create a dp array and we'll check for whether that particular index is stored in this value or not. And if it does, we'll just return the value. Otherwise, in the end, we'll just store in that particular index that particular value in that particular subtree. So and one more thing, I'll just pass this by reference because we don't it doesn't want to change any value and we don't want to overhead this and recursion call. So just run it. Think that works, and I'll just submit the solution. Voila, it's submitted. So that's how that's how extra characters in a string works for this solution. And if you had any queries, do let me know in the comment section so I can help you out. And I'll just quickly go through the solution what we're doing. We're just creating a map. So in order to make a quick search and for the particular search we'll make it as off one because maps will search in off one time complexity. So just go through entire dictionary and we'll create a hash map for that. So we'll make a dp array to store the recursive to solve the recursive overhead and store in a particular index. And what we this helper function does is it will break at each index and it will store that particular minimum sum in a dp array. So how does it goes? So it will look from index to that entire string and it'll just append each string. So if that string is present, if that string is not present, we'll just make extra as that particular template. And from there to next other left out string, I'll recursively call the function. I'll get that extra current extra and I'll minimize this for the minimum answer as previous min answer as well as the current plus extra value. So and that will be stored in the DP array. So that's how the solution goes. And if you like this video, do subscribe to my channel, share it with your friends, and like the video. That's it for today's problem of the guys. See you tomorrow with a new problem. Thank you. Bye bye. See you tomorrow.